Okay, we will continue the lesson. The previous lesson, you have already learned about oxidation number. You have learned what is oxidation, what is reduction, oxidizing agent, reducing agent. Now, how are you going to use it for the examples of question? In your textbook, there is a lot of explanation, a lot you need to study. So I'll just show you what is the important ones. We'll just go through with the important ones. The remaining, you take time and you study, you practice by yourself. Take time, write it in a piece of paper, the equation. You see each oxidation number. You see which one is the oxidizing, which one is reducing. You refer the reactants. Okay, can? Okay. Look at your textbook and page 411. Page 411 of your textbook. Just an overall, because if you know the summary, then I think you will understand better. No need to read everything, it's so much actually, so heavy. Just know what is important. Okay, this is the basics. What is oxidation reaction? What is reduction reaction? If it is oxidation reaction, meaning there will be an addition of oxygen, gain of oxygen, or removal of hydrogen, increase in the oxidation number, loss of electrons. Now, I told you clearly that the best way to identify oxidation reduction, just check on the oxidation number, whether there's an increase or decrease. That's the most easiest way, right? For reduction, it's exactly the opposite. You will either have a removal, a loss of oxygen, a gain of hydrogen, a decrease in oxidation number, or a gain of electron. Again, the easier way is you just look at the oxidation number. Compare your reactant and your product. Okay? Now, what is redox reaction? Redox reaction is when oxidation and reduction happens at the same time, happens simultaneously. You have to remember the definition of redox reaction. Okay, next, usually the questions, the structure question or the objective question, it's only based on this. It's only based on this, where they will give you combustion of metals in oxygen or chlorine, and they will ask you which one is the oxidizing agent, which one is the reducing agent. Heating of metallic oxide with carbon, changes of iron 2 to iron 3 and then iron 3 to iron 2. Certain chemicals or certain element or certain ion or compound can be both oxidizing and reducing agent. Now you have learned last week examples of oxidizing agent, examples of reducing agent. Remember, I did ask you to highlight. Wait, I'll just show you now. Remember this page 387? I did ask you to just go through this table. So you have learned some example of oxidizing and reducing agent. Now there are some ions or compounds or elements which can act as both oxidizing also as a reducing agent, but in different reaction. So that one example is Fe2 plus and Fe3 plus. They can be both oxidizing and reducing, but in different kind of reactions. So we are going to learn about them. Then we will learn about displacement. What is displacement? You have learned in your chapter 6 last year. You also learned in your chapter 8 displacement of metal from salt, halogen from its halide solution. So if you have forgotten all that, I want you to recall first before I teach you. And then we will learn transfer of electron and distance. This is something new. All this you actually already learned last year. You learn in the salt chapter, you have learned in the electrochemistry, but you just don't realize them. But you actually have learned them. So I'm going to go quickly on this. This one is the new one, which I will take time and teach you, so don't worry. Okay, redox cell. Redox cell, it means, remember last year you learned about dry cell in electrochemistry. You learn about dry cell. How does dry cell works? How does voltaic cell work? Voltaic cell is opposite of electrolytic cell. Which one is chemical reaction first and then produce electricity? Chemical reaction, or you say it as chemical energy to electrical energy. Which one? And then one of it is electrical energy to chemical energy. I'm not going to tell you now. I want you to recall. Go and read back. Okay? Redox cell is another cell. It's like you have learned electrolytic cell, you have learned voltaic cell. This year you're learning redox cell. Okay, I'll teach you. Okay, you know what is oxidizing agent and reducing agent already. Oxidizing agent means it will bring oxidation to another substance, but itself will be reduced. Electron acceptor, meaning it's accepting electron, right? When I accept electron, meaning I'm more negatively charged, meaning I have been reduced. I have been reduced. For example, if you don't understand, let me write it down. Let's say chlorine is an example of oxidizing agent. Okay, it will oxidize another substance, but what will happen to itself is it will accept electrons and it will be reduced to chloride ions. Okay, balance your equation. It will reduce to chloride ions. It is an electron acceptor. This is called electron acceptor. It will oxidize another substance, but itself will be reduced, because here the oxidation number is 0. Here the oxidation number is -1, right? I always tell you, don't refer to your balancing equation. You only consider like this. Like this, you don't need to consider. So for this, it's -1. Is there a reduction? Yes, right? Okay. Reducing agent is agent that will reduce another substance, but itself will be oxidized. It's an electron donor. So for example, metals like magnesium, right? What will happen is, in the end of the reaction, it will become like this. So it donates the electron. It's an electron donor. It reduces another substance, whereas itself oxidize. Okay? Okay, and then the rules for determining oxidation numbers. And last week we learned uncombined element, meaning elements, molecules will have 0. The sum of oxidation number of all the atoms in a polyatomic ion is equal to the charge of ion. Meaning, for example, let's say it's like this. I ask you to find the oxidation number of this. How would you find? X plus 4 negative 2 is equals to the charge of this entire polyatomic. Polyatomic means got more than 1 atoms and got a lot, right? Got 4, 5. So it's polyatomic ion. And here, is it equals to 0 or -2? It's equals to -2. Then you find your X. That's what you are trying to say. The sum of the oxidation number of all atoms in a compound is 0. For example, let's see, like this, CH4. Okay, I ask you to find this. So how do you find? X plus 4 positive 1 here is equals to, the whole thing here is actually 0. Then X is equals to 1. Okay, that's what they are trying to say. So this is what we are going to learn for this whole week. Okay, that's the summary of what we're going to learn. Last week we learned about oxidation number, right? Now you are going to learn about how to name the compound. How do you want to name the compound? Page 393. Okay, for an ionic compound or covalent compound that contains a metal with more than 1 oxidation number, you have to use Roman numerical figure in the brackets. You have learned this. You actually know this, just that you don't realize that. Like for example, iron, you always write iron 2 or iron 3, right? Why? Because we know iron got 2 oxidation number. They are transition element. You learn this already. That's why I tell you this chapter, it's so much in detail, but you don't need to know everything because you actually already know them. So you don't stress out that they got so much to read. No, it's just simple stuff. Okay, so this one you know. Okay, look at this one. This one, copper, we also know copper is a transition element. So when you write, you are going to write copper 1 or you are going to indicate copper 2, right? Okay, and then same goes to manganese. Also got different oxidation number. Okay, so if there is different oxidation number for the metal, I must indicate them. So let's say for example, hmm, let's say for example PbO, and let's say PbO4. How will you name them? This one, how do I name? If you're not sure, you have to find the oxidation number of the lead. Okay, let's say I don't know what's the oxidation number. So X plus -2, sorry, X plus -2, because oxygen is -2, the whole thing is 0. So X is -2 equals to 0, X is +2, right? So here, how do I say? Lead 2 oxide. This is how I name them. And this is capital Roman numericals. This one, how would I name them? I'm not sure, right? I don't know. So let's just check. I don't know what is this. So X plus 4 -2 equals to 0. X -8 equals to 0. X is +8. Hey, wait, there's a mistake. Yeah, I did a mistake. No. It's not like this. Wait, let me just check. Oh, sorry, it's not 4. It's supposed to be 2. I'm sorry, I made a mistake here. Let's say PbO2. Sorry about this. It's supposed to be 2. I accidentally put it 4. Let's say PbO2. How do you name them? I don't know what's the oxidation number, so I find -2 here. X minus 4 equals to 0. X is +4. So we know this lead is +4. How do you name them? Lead 4 oxide. Okay, so it's only for the transition elements or metals that have more than one oxidation number, you have to write like this. Okay, Ken, this is something that you already know. So the common questions for SPM, they always question about Fe, iron, copper, lead. This is very common in SPM questions. Ken? Okay, next. The next rule. Point number 3. The metallic elements in group 1, 2, 3 in the periodic table always have oxidation number +1, 2, 3 respectively. According to IUPAC, the Roman numerical figure is not used. Why? Because they only have one oxidation state. What they are trying to say? They are trying to say that, okay, now you know that transition element. Where is transition element? That is group 3 to group 12. You know all those elements, they have various oxidation number. So meaning for that, I have to write them like this. But for metals, that is group 1, 2, 3, I don't have to write like this. Why? Because they only have one oxidation number. If only have one, you no need to write the Roman numerical, which you also already know this. Okay, when you want to write potassium sulfate, do you write potassium 1 sulfate? No, right? You always write potassium sulfate only, right? So you actually know all this. Now you are just learning the theory behind them. Why I don't write potassium 1? Because this belongs to group 1. Group 1 only got one oxidation number, that is +1. Another example, magnesium. Why I don't write magnesium 2 nitrate? Because they only got one oxidation number. So why want to make life confusing? You only write all this Roman numerical for metals when they have more than one oxidation number and they are actually transition metals. Can, you understand, right? So group 1, 2, 3, no need to write all this. Transition elements must write because they have more than one oxidation state. So far, okay? Can, right? I'm going very slowly. Next, for negative ion that contains negative ion, so you are referring to polyatomic ion. Polyatomic ion means something like this. You see, got a lot of atoms here, got 5 atoms here, and the charge here is negative or positive. It is, what do you call it? It is not zero charge. Okay, that's called polyatomic ions. Okay. For a negative ion that contains a metal, negative ion that contains metal. Later you're going to learn about negative ion that contains non-metal. So careful over here. For a negative ion that contains a metal with more than one oxidation state, Roman number is stated in brackets after the name of the metal, and the name of the metal ends with ATE. All this while you have learned that metal in a compound, the name never change. It's only the negative ion change, right? So meaning, for example, for example, let's say NaCl. How do I name this? Sodium chloride. Who is changing the name now? Is the non-metal, right? Because this one, suppose the name is chlorine. But look at here, the name changes. The metal, name no changes, right? Let's go through another example. How do I name this? I name this as copper 2 bromide. If you notice, copper, no changes in the spelling. Okay, why I put here 2? Because copper, remember, copper will have 2 oxidation state. So I got to tell which one. And if you notice, it's the non-metal that is changing the name. Another example, you spell it as magnesium oxide. So who's changing the name? The non-metal. But now, what are you learning? A new thing, whereby the metal, there is changes in the name, it ends with ATE. But for which condition? For which condition? When it has a negative ion. When it has a negative ion. Okay, we go through examples so that you can understand. But I'm telling you, this example is something you know actually. Okay, you see, again, for a negative ion, and then the metal will end with ATE. So for example, this is actually manganese metal. Mn, okay, I'll just write here. Mn is actually a metal. But can you see the name, the spelling ends with ATE? Instead of spelling it as manganese, it becomes manganite. It refers to the negative containing manganese metal, MnO4 negative. Okay, for this one, that means, let me show you. I'm not sure if you understand. MnO4 negative, right? If you notice, there is a metal here, and this whole thing, it's a negative ion. The whole thing is a negative ion. So how do I name this? How do I name this? First, I need to find the oxidation number for this. Let's say I don't know. So it's X plus 4 negative 2 equals to negative 1. X minus 8 minus 1. X minus 1 plus 8, x is equals to positive 7. So we know this filler has positive 7. Okay. How do I name this? This is actually a transition metal. How do I name this? And this is a negative ion. So I'm going to name it as, instead of like this, because the name of the metal is actually this, but instead of like this, I change this is ATE. It is 7, right? Numerical for 7 is ion. Okay, so it's manganate 7 ion. You see here? It's manganate 7 ion. This one, chromate 6. Chromate 6. So for this example, I show you, CrO4 negative. Okay, how do I want to do this? Again, I find the oxidation number. So X plus 4 negative 2. I think there's a mistake, yeah. Negative 2 here. So X minus 8 negative 2. This one you know lah. 8 come here and then it's positive 6. Okay, so how am I going to name this? I know this is actually chromium metal. Chromium metal, which is a, what do you call, a transition metal. But there is a changes in the spelling. It's going to end with ATE. So instead of writing like that, it's chromate 6 ion. Can you understand? So the concept they are trying to tell you is, when the metal is bonded with a non-metal and there is a negative charges for the entire compound, you have to name it in a way where they will have Roman numericals as well as the metal, the name changes. That's all. Alright, Ken? Okay. I want you to do is, I want you to take some time, go through like how I did all this. I want you to take time, don't be lazy, take time and try for all this. Okay, then you'll be able to do it. Okay, if you notice here, right, I just give you one example. How do I name NO4? I already learned just now, it's manganate. Alright, and the potassium, there's no changes in the name of the potassium. I don't even need to write potassium 1 because I know that potassium has only one oxidation number. Okay, Ken? So you go through all this later. The last one. The last one, oxo anions are anion, negative ion that consists of oxygen atom and another non-metal. So here you learn about oxygen with metal, but here you are learning with oxygen and non-metal. So how do you name them then? So example, oxo anions are this non-metal that shows more than one oxidation number. Non-metal. Now we are studying the non-metal that shows more than one oxidation number. So the Roman number in bracket is stated after the non-metal. It's exactly opposite with what you learned just now. What you learned just now was you write the Roman after the metal, the name of the metal got changes. Now you are learning the non-metal, the name will change, and you're writing the Roman letter behind the non-metal. Okay, so how? For example, this one. How do you name them? Sodium sulfate 4. Why I name it as sodium sulfate 4? Because this sulfate carry a positive 4 charge. Okay, so sodium sulfate 4. Okay, sodium sulfate 6. What I want you to do is, I'm very sure in this way you cannot understand, so I want you to take a piece of paper and do it like this to find the charges of sulfur. I just give you one example. Okay, the first one, right? The first one, Na2SO3. So we know that this one comes here, this one comes here, right? So it's actually SO3 2 negative. Alright? I want to find I want to find S. X plus 3 negative 2 equals to negative 2. X 3 times 2 is what? 3, sorry, I didn't. Okay, so you write like this, huh? X negative 6 negative 2 X so we know this sulfur is 1,4. So how you're going to name them? You're going to name them as sodium sulfate 4. Okay, can? Why is because, again, earlier if you notice, this sulfur is a non-metal, oxygen non-metal ion. There's a changes in the name, and then you write here. You don't go and write sodium 4 sulfate. You don't write like this. Why? If you write like this, you're trying to say the sodium has plus 4, which is completely wrong. You're trying to say the sulfate has plus 4. Now please understand, this one is completely different than this one. Can you see the difference? So I don't want you to get confused. Now what I want you to do is take a piece of paper, try for everything, and then you see why exactly they name like this. Can? Okay, the remaining I will continue the next lesson, because if I teach you so much now, you'll be so confusing. I'll teach you one by one. Okay? So later I give you some assignments about this, about the naming. So today you learn about naming. Tomorrow we will continue with all this. Tomorrow we will continue with this one. I'll go one by one, I will teach you. Alright? Okay.